Today, we're going to talk about something that quietly shapes our world, from the deepest oceans to outer space. It's a powerful tool that works behind the scenes of global politics, and it's called science diplomacy.
So here's a question for you. What could possibly connect a potential war on the moon with the fight against a global pandemic? I know, it sounds like a weird riddle, but the answer really gets to the heart of how we tackle our biggest, most complicated shared problems.
And that common thread? Well, it has a name. It's a concept that was really locked in at a big conference back in 2009, science diplomacy. The easiest way to think about it is as a framework for working together, and it's built on three main pillars.
All right, so pillar number one is science in diplomacy. This one's pretty straightforward. It's all about making sure that when diplomats are making huge decisions, they have the best scientific advice possible. The classic example, the Intergovernmental Panel on Climate Change, the IPCC. Their reports are the scientific foundation for basically all global climate talks.
Then we've got Pillar 2, diplomacy for science. Now this is when you use the tools of diplomacy, treaties, negotiations, international agreements, to make massive science projects actually happen. We're talking about projects that are so huge, so expensive that there's no way any single country could do them alone. And that brings us to our third pillar, science for diplomacy. This is where things get really interesting. It's where science itself becomes a kind of soft power, a tool for foreign policy. The idea is to use scientific collaboration to build bridges, create trust, and find a common language, even between countries that have really tense political relationships.
And look, this isn't just theory, right? We see it in action all over the place. The IPCC is a perfect example of science times diplomacy. The Large Hadron Collider and that giant IDA fusion project, absolute triumphs of diplomacy for science. And then there's the SESME research facility, which brings together scientists from all over the Middle East, including from countries with, let's say, complicated relationships. That's a brilliant example of science for diplomacy.
Okay, so now that we've got the framework, let's put it to the test. For our first case study, we're heading to the final frontier to see how these ideas apply to the new challenges we're facing in outer space.
And the stakes here are just incredibly high. As Stephen Freeland from the UN points out, back here on Earth, fighting over resources has been a constant source of conflict throughout history. So the really big question is, are we just going to repeat those same mistakes when it comes to resources on the moon or on asteroids?
This basically puts humanity at a fork in the road. One path is cooperation. We could create common rules for peaceful and sustainable use, making sure that space is open to everybody. The other path, well, it's a free-for-all. It risks creating a tragedy of the commons in orbit, sparking all new geopolitical tensions and kicking off a brand new and probably pretty dangerous space race.
Now, we aren't starting from zero. The 1967 Outer Space Treaty laid the groundwork by declaring space a global commons, something that belongs to all of us. But today, with private companies and new technologies making things like lunar mining a real possibility, that core principle is being tested like never before.
Okay, so from a potential future conflict in space, let's bring it back down to Earth and look at a real crisis from our recent past. A crisis that pushed this whole idea of global cooperation to its absolute limit. Our second case study looks at how the science diplomacy framework held up under the intense pressure of the 2009 H1N1 pandemic. At first, everything worked just like it was supposed to. On April 11th, Mexico flagged an unusually nasty flu season. By April 24th, the World Health Organization was officially notified, and just one day after that, a global public health emergency was declared. That kind of speed was only possible because of a brand new international rulebook. And that rulebook is the Revised International Health Regulations, or IHR. This was a massive upgrade from the old system. The old rules only covered a few specific diseases, like cholera and plague. The new rules, they cover any potential public health emergency. The WHO also got more power. It no longer had to wait for a country's official report. And maybe most importantly, the response shifted from rigid, old-school border controls to flexible responses based on the actual evidence. This was a huge deal. But here's the thing. Even the best rules on paper can fall apart when they meet reality. The WHO explicitly said it was unnecessary, but Egypt ordered the slaughter of its entire pig population. Pork imports were banned. Some countries started quarantining travelers based on their nationality, not whether they were actually sick. It just goes to show you that in a real crisis, fear and domestic politics can sometimes shout louder than global scientific consensus.
So let's pull these two stories together. We've looked at the future of space and a past pandemic.
What do they tell us about this bigger cooperation challenge, and why is getting this right so important for all of us?
Well, first, let's talk about the cost of failure. Just the response to that 2009 H1N1 pandemic had an estimated price tag of $18 billion. That's a staggering number, and it really hammers home the massive consequences when we don't cooperate effectively, whether the threat is a virus or a conflict in orbit.
And this really gets to the heart of it all. Science diplomacy, it's not a magic wand. It's a constant, messy, but absolutely vital negotiation. It's this permanent push and pull between what the global evidence tells us we should do and what individual nations, guarding their own interests, ultimately decide to do.
And what makes it work or not work really comes down to things you can't just write into a treaty. Its success depends on trust. Trust between scientists and trust between politicians. It depends on transparency and sharing data openly. And most of all, it depends on everyone sharing the basic understanding that you just can't build a wall around a global problem. They demand global cooperation.
So that leaves us with one final thought to chew on. From the rise of AI to climate change to the health of our oceans, what do you think the next great global challenge will be? The one that's really going to test our ability to work together?